You get another book. Come here. That's Database Nation. I only got 2. All right, I got some low-quality hacker jokes there, but I'll come back to that. I'm Robert Hansen, no relation to the CIA spook, just spelled differently. I'm talking about htaccess today. Hopefully you all kind of know what that is or have had some experience in it a little bit. But if you don't, I'll just give you a brief definition here. As whatis.com defined it as htaccess is the default name for a file that's used to indicate who can and cannot access the contents of a specific file directory from the internet or intranet. Blah blah blah. That's half right. That's kind of sort of right. What it really is a file that's meant to act as a secondary file to your http.conf file. So it's a directory-specific HTTP conf file, essentially. So you can put configuration information in there. So as far as protecting stuff, you can have something like if it's browser-specific. If you want Netscape browsers to go to a certain place, you can do stuff. Any kind of environmental variables, timestamps, anything that you can glean from a session or headers is something that you can parse apart and do something with. So my thesis, or the point of this talk, is that htaccess can be a robust solution. Right now, it's not. There's a lot of problems with it. Am I talking loud enough? Can everyone hear me? Right now, it's kind of insecure. It's got several problems. Let's see. Namely, it's insecure against sniffing, brute force attacks. I mean, you all know, like Whisker, Rainforest Puppies. Whisker, for instance, is a good example of that. WFA Hack, which I'll get into in a second, and a little-known fact that it can actually cause denial of service attacks if you do brute force attacks. You can also do replay attacks if you're sniffing and that kind of stuff if you're not using SSL, secure socket layer. But basically, what I'm going to be talking about is that it's a basic type authentication. That's really the heart of it. That's why most people use it, is to have directory access control. Most people think of it when they think of htaccess as this pop-up window, and that's something that's rendered by your browser. That's not actually has nothing to do with htaccess at all. That's just a kind of GUI interface, so you can put your password in a really easy sort of way. But really what it is sort of elaborate header scheme. Let's see. It's out-of-the-box Apache protection, directory protection. I've seen things do something like IP-based authentication, for instance, is a great example. Like if a user is coming from a specific place, you can give him access to that specific directory. Like I don't want anybody from outside my internal network to be able to access this particular directory. I can do some directory access control that way. That's a typical .htaccess file. And when I say typical, it doesn't mean that's the way it should be. It's just that's what most people will show you. Basically, the auth user file is where your htapassword file is stored, which is basically a flat file with usernames delimited and passwords that are hashed, delimited by a semicolon. It's pretty standard. You can also use databases. I won't get into that, but auth type basic is giving you the type of authentication you're going to use. There's a couple of different ones, but I'm not going to go into those very much. Auth name is just what the GUI shows you. It says domain and then protected, or whatever you want to put there. It's not useful. The limit doesn't even really need to be there. You should just have required valid user. This is just a typical, not something that I recommend using. I'm going to use a variation on it. Okay, so what we're trying to stop here is basically brute force attacks. That's the most common. That's what most people are going to be talking about. The attack signature is you have zombie processes. You'll just be sitting there one day and your server's load will spike. You have all these zombie processes and you won't know why. If you gracefully restart it, it won't actually bring your server back up. It won't help your load. But if you do a full stop and start, it will improve it for a while. You'll notice that it'll just go, right back down to normal, and then depending on whether they give up or not at this point, it'll go back up. Many attempts from the same IP address, sequential usernames, like AAAA or that kind of stuff. It's pretty obvious when you look at the log files. Okay, so this is WWW Hack. I don't recommend using WWW Hack anymore because the website has been kind of nuked since then, and the WWW Hack doesn't do what it used to do. But here's what it used to do. It has two hacking methods or cracking methods. One of them is checking for 200 OK return headers, which basically just says, yes, your password is OK, and yes, you are allowed to go to this directory. And then it cuts off right after it gets the headers. So after it receives a certain amount of packets, just getting that first header, then it cuts off and doesn't care about the rest. It actually closes its socket. The other one is a pattern match. So it looks for strings like welcome. Like obviously you're not going to get a welcome page if you failed password attempt, right? I mean, so you can check for certain strings. And this is the much nicer of the two methods. So with the first one, let's go into that a little bit. This is where you can cause denial of service attacks. If you have a web server set up, and let's say instead of having your private directory, you don't have an index file in there, you have an index.cgi file, not an HTML file, but a CGI file, or an ASP or something like that. Well, we're talking about Apache, so CGI script. And you're doing something complicated, database access, or doing something random, something that requires more than just printing out some text, or maybe that is all you're doing is printing out some text, but it's dynamic. If they shut off the socket after the first a couple hundred characters or something, and you're not getting the rest of it, you have all these Apache processes just kind of sitting there trying to reply to a socket that's not listening. So basically what happens is they hang. And depending on how many, imagine, WWW Hack does this many times a second, of course, to get the maximum efficiency in brute force. So you have, anywhere from 8 to maybe 100 different sockets open that aren't getting cleaned up right away. And depending on your time to live or how long it takes the Apache daemon to kill off those processes, you could have literally hundreds and hundreds of processes that are just sitting there. And that might actually take up the amount of processes that you allow, effectively denying service. And the other one is much nicer. Like I said, if you allow the text to be downloaded, it's just like a browser. It doesn't, there really is no difference. Although it's kind of annoying and it is damaging your bandwidth and that kind of stuff, it really doesn't. It isn't really that much of a problem, except keeping passwords safe. My first test to try to stop this was by returning 401 errors regardless of whether they had been, that means denied, regardless of whether they had been denied or not. So they go to the web page, they type in their in the pop htaccess window, they type in their username and password, and then hopefully what would happen is they'd continue to send their username and password, and despite the fact that they'd be getting a 401 error, they'd still be sending the correct headers, and so they'd still get the content. This had mixed results. IE and Netscape don't act the same. IE is actually worked properly for once, although in a weird way. Actually, they don't follow a very secure paradigm, I guess. After I returned 401 error, it kind of doesn't make sense to keep sending the same wrong password over and over and over again, but it does, which makes this hack work properly. Netscape is smart about it and says, hey, well, obviously this password's not going to work. I'm not going to keep sending it over and over and over again. And so it has the side effect of not working and popping up an htaccess box every time you go to a web page. The second method I tried was returning 200 OK in all instances. So why am I doing this at all? Well, if you go to a web page as a client and you see certain strings, or you can tell differences in the two, you can obviously check for that and automate this. So I'm trying to make it impossible to automate, or next to impossible to automate. So if you return 200 in all cases, hopefully the idea is that they can't do something like just check for the headers, and the first of the two attacks that WFA Hack can perform won't be valid, won't work. The problems with this is it doesn't result in a pop-up window, of course, because you're not passing the 401 error to the browser, which I said is rendered by the browser. That's a GUI. That has nothing to do with how htaccess work at all. So the only way I could get into the site is by doing this like user:pass thing in the URI field, which is pretty lame and subject to all sorts of other problems. So I took a modified approach. I put a form submission box. So I had a login page with a username and password field, and that posts to a script, which then interprets that information, checks it against a database or whatever, a flat file, doesn't matter, and then marks it client-side with a token, just a cookie that's a one-time hash, probably with a string on the back, a date stamp or whatever to make it unique. And it's marked client-side that's a valid cookie. So what we're going to do now is we're going to pass cookies on both whether they are denied or whether they are allowed. One is marked client-side, they are accepted, one is not. Okay, so now we need to discuss how we're actually going to use this htaccess script a little. There's three methods that I know of. There might be more, there probably is. The first one's auth external, and that's the one that is tried and true and I've had the best success with. It's an Apache module. It's pretty standard out of the box. It's not on any of the Apache org lists. You can't find it there. Just search for auth external and you'll find it on Google or whatever. Mod Perl, I've had very poor results with. It has a problem with inter-process communications, and the short story is eventually, randomly, it'll die, and you can't clean up processes nicely, and so what you have to do is take down the web server, kill all the semaphores, shared memory, all that crap, start it up again, and then how is that saving you any time? You still had a denial of service attack. So that's not a really great answer. And the third is a proxy, which I'm not really going to talk about much unless I have a lot of time near the end. But it's a really good idea that Vacuum from Tektotronic gave me when we were discussing this. Okay, so one of the problems is, yeah, we can do this thing with the headers and make the headers look the same, but what about the actual content of the web page? We still have the problem of them searching for strings. So one of the ways that we're going to try to solve this is by using frames. I wish I had a whiteboard. They promised me a whiteboard. But essentially what this is going to look like is you're going to have a 100% frame inside of a window. And that window doesn't do anything. This is basically just going to be a CGI script that prints out either this information or it prints out what's inside mainframe.html. This is going to get really confusing. I actually have a compendium to this speech that's explained this in much more detail. I'm kind of glossing over some of the important parts. That's supposed to be on Security Focus today, although I don't know if that's going to happen or not, just because I haven't read my email. Okay, but this private index.cgi mainframe, that's just a query string. You can't use query strings with auth external. It just doesn't pass that particular that environment variable. So you have to use like request URI or something. I forget what it is. That's all marked on my compendium. Okay, since the user has not been authenticated, if the user goes to private index.cgi, which should be our private page, that's the beginning page that we're interested in showing them, they'll get redirected to some script. I'm calling it 401.cgi, which is determined by an error directive that's for some reason I didn't put it on this page, or maybe. Oh yeah, I did, right below it. Error document 401/401.cgi. That can be wherever you want it. But basically what you're telling it is that you're telling Apache to send them, if you get the 401 error, send them to this particular script. And let's see, that script basically just prints out, depending on whether they've been there before or not, and it can tell that because you have a cookie and it can mark all this stuff client-side. If they have been there before, then you print out the mainframe.cgi. If they haven't been there before, you place the cookie and you mark it as a one-time try cookie. So you don't allow them to continuously keep trying over and over with that same cookie, and that will allow you to detect how many times they've been logged in, how many times they've tried that, and they can't just I'm trying to make this hard to automate. Mainframe.html in the slash directory, which is your root directory, is going to be your login page. That's just going to have your username and password, and that's pretty much all it's going to have. Inside the private directory, that's going to be your private content. That's your actual meat of what you're trying to protect. I realize the names are confusing here because they're kind of intentionally supposed to be. What we're trying to do is make it impossible for them to inside mainframe, unless they have a recursive function built, a script to traverse through the website like wget does, for instance. It's going to be very hard for them, or actually impossible with this setup, to detect that there's any differences in those two websites because they get the exact same content because we're using frames. Everyone understand that? Okay, so that's kind of small. Sorry about this. My first time using PowerPoint. The logic flow goes like this. They go to 401.cgi, which is your login page, and that places the cookie, which allows you to have a one-time try authenticate, or a try to see if your username and password work. And it also prints out mainframe.html inside your root directory, which is your login page. Once they type in their username and password, it sends them to some other script. Actually, this doesn't have to be this way. You could actually have it send to itself, but I thought that'd be too confusing for logic reasons. But whatever, just check.cgi, just some other CGI. Checks to make sure the cookie exists. If it doesn't, then they obviously aren't they don't have cookies, and we need to tell them that they need to turn cookies on. And if it does exist and the username and password are correct, it marks it client side that is a valid attempt and that they are authenticated. So it marks that all client side in a database, and then sends them to CGI bin auth.cgi or whatever, wherever your authentication script is, which is marked in your htaccess script. That's a part of what monauth external is for, is to show you, to show Apache where an external authentication program, and this can be any kind of authentication. It could be as simple as what is your IP address, yes or and you return 0 for okay and 1 for no, kind of backwards, but. And then regardless of whether check.cgi found this to be true, it sends you to auth.cgi for the reason that it needs to look the same. You need to have the same you have to have the same flow, otherwise they can detect that. If it doesn't look exactly the same in both instances, they will be able to tell without building a recursive function that you are which one is valid and which one isn't. And if they aren't valid, you send them back to 401.cgi, give them a new cookie, and you start the whole process over again. If they are valid, you send them to private index.cgi. Actually, I take that. Okay, so we got to take one step back. How auth.cgi sends you to 401.cgi is it doesn't send you direct, doesn't print location to 401.cgi. It prints location to private index.cgi. It actually sends you to the private page. But because you aren't authenticated, it'll send you back to auth.cgi saying, yes, are you valid or not? And since you aren't valid, it'll send you to 401.cgi just by virtue of the error directive. Kind of confusing, I'm sorry. So if they are authenticated, they go to index.cgi, this index page, and it returns a 200 OK header, just like 401.cgi does. Prints out, puts a new cookie on there, but this cookie is going to be it has to look new because that's what 401.cgi does. It places a new cookie on, but this cookie will be marked client side as like this, now they are authenticated, and this is their new cookie. And it also prints out mainframe.cgi or mainframe.html, which is the meat of your content you're trying to protect. Okay, so why the cookie? Well, fairly obvious reasons. It's really hard to detect. You can't use IP-based authentication. I can't stress that more. It doesn't work, especially if you have stuff like AOL, where like they have like 54 IP addresses and 2 million users or something. I mean, if you block one of those people or 5 of those different IP addresses, you just effectively denial of service attack. You know, you've allowed yourself to block a huge percentage of people who probably weren't attacking you. The cookie is also going to be extremely difficult to guess because it's using a cryptographic, hash, MD5 or whatever, blowfish, and has this timestamp on the end. You don't have to send sensitive information over and over again. This is something in combination with SSL. You totally, and hopefully if you use something like one-time pad cryptography, that's OTPW, that's a great program, by the way. You can make it so that you don't have to keep sending the same information over and over again to the browser. In fact, unless you're like the NSA or something, it doesn't. Even if they break SSL, it doesn't matter because you're still using a one-time pad. You can actually make using this method, you can make it stronger than anything out there, literally, as far as just straight-out security. Let's see. Okay, this is content masking. We kind of already talked about this. Okay, the second part, working towards 100% perfection. I got this weird idea in my head. I thought that, okay, if they are able to build a traversal function and they are able to check for check the contents of mainframe.html, they could theoretically do string checking. So I thought, okay, what I'm going to do is I'm going to take all the content from index.cgi or from mainframe.cgi, from both of the different mainframes.cgi, and put them in comments on each other's. So regardless of which one you go to, you still have the content of the other one inside the HTML that's returned. So if you search for a string like welcome, you're going to find it even though it's not viewable. You can't actually see it, but it's still in the content that's returned to you. I mean, this is a dumb function. It's not like checking to see what is visible and what isn't. I mean, it could be made to do that, but so then I thought, okay, well, now that doesn't really solve anything because they can check for the string that is the web page that is getting returned to them. And if they're not getting the exact string that is this really long web page with lots of new line characters between it, you're essentially you're not solving anything. You're just obfuscating the problem. So I thought, okay, I'll take it one step further. I'll do an ASCII hex translation of all the characters. So kind of randomly dispersed. Like A, for instance, will turn into ampersand. This is a typo here. It should be ampersand 41 semicolon. And spaces will turn into ampersand 20 semicolons and all these different things, and randomly do it. Build this all off of CGI script and randomly do it. And that ended up not solving any problems, and it's kind of a weird reason. Okay, my thought was if they are able to have access prior, and they can do something like they know where an image is, for instance. I'm going to be returning 200 OK. Let's go back here a couple. Oops. Oops, I'm going the wrong way. Sorry about this. Okay, crap. Okay, see, I'm returning content type text slash HTML. And if, for instance, it's image, that doesn't make sense, of course, because it's not going to be text.html. It's going to be an image file. And the same thing's true with multimedia. I mean, you're going to run into tons of different instances where you're going to have a mismatch of headers, which is a real problem. But the solace here is that hopefully we're doing something smarter than that. Hopefully we're not allowing them to log in like a few million times. If they can search for a string, that's fine. But if you allow them to log in 4 million times, I mean, that's your fault, right? People, let's see, like Wells Fargo lets you mistry like maybe 10 times or something. Why do we need to let them, try several hundred times, effectively causing denial of service attack or spiking load or whatever we're doing? It doesn't make any sense. So I think probably 10 times is more than generous to know that they don't have the right password. And it doesn't mean you have to completely IP chain them off your net or anything like that, or put them in a firewall. You don't need to do that. All you need to do is put them to a web page saying, sorry, you need to call us and say, or email us, or fill out some web form so we can verify you are who you say you are, which opens you up to another form of attack, but I won't get into that. That's your problem. Okay, so worst case, I've actually seen this happen a lot. I've worked on this for the last 3 years. I've seen as many as 10 connections a second, and that was coming from 10 different hosts. And we were able to trace that one particular instance. It was one guy in a computer lab late at night, able to, commandeer a bunch of computers in the lab, at university costs, and just destroy us. And that was, 20 different proxy servers, yeah. Because that was one of the functions of WFA Hack, is that it could actually work with proxies. So does it help me to know who this guy was? Well, in that one particular instance, one of the proxies he was using told me which IP address he originally came from. So yes, I could actually call this admin wherever he was and get him kicked off. But for the most part, it doesn't actually help you, because for the near term, what's still happening is you're getting these hundreds and hundreds and hundreds of requests. It's not actually going to solve you it's not going to fix anything immediately to know who he is. Okay, so now I really wish I had a whiteboard. Okay, Morses Attack. You probably all know about IP spoofing, but I'm going to give you a real brief overview. You have machine A over here and machine B over here, and machine B is trusted to machine A, and you want to attack machine A. So, and it's trusted by IP address. It knows that this IP address is valid to log into certain directories or execute certain CGI scripts or whatever. And this is very, very, very common. This happens all the time, especially in credit card verification services, and I'll get to that in a second. So the idea is a three-way handshake. You send a SYN packet, with initial sequence number in it, and return a SYN-ACK and then an ACK. So, and if you send a spoofed SYN packet, it'll send a SYN-ACK back to the original host that you're spoofing from, which doesn't really help you. Okay, so now you have a halfway connection. You can't actually intercept unless you're spoofing or unless you're sniffing on the network. But assuming you don't have that kind of access, assuming you're a hacker that's outside both LANs and you don't have access to the routers or whatever, you can try to guess what the next sequence number of the SYN-ACK coming back is. You already know what the ISN number that what yours is going to be. It's just yours plus 1, but you don't know what his is. So I actually talked to Robert Morris. He's the guy who invented the Morris worm I'm sure you all heard about. I talked to him about this, and he said it's still valid. It still works. He invented this in 1985. I reinvented it. I didn't know he'd done this. He believes this is still totally valid. In fact, Nmap, if you look at the source code for it, it actually goes through and checks all the. That's one of the things it says. If you run it, it says difficulty rating, and that's based off of the difference between two returned SYN-ACKs or two different ACKs. So trying to guess what the difference of the two ISN numbers. If it's like 2 every time, it's pretty predictable, and you can do stuff like spoof entire sessions if it's that predictable. But the higher it is, theoretically, the harder it gets. Although that doesn't really mean anything. That could be based off of how much traffic that particular host is getting, or maybe randomness. It doesn't take in randomness into account. There's been some work done in this already, but mainly the hard part of this is the statistical analysis of the data that's returned. It's not actually the actual spoofing part is really easy. Been done. And this program's actually already written. I didn't write it. It's called isnprint.c. It was released on Technotronics newsletter quite a while ago, but it doesn't have the statistical analysis portion of it, which I'm hoping someone else will write for me. Let's see. So, okay, because this is a spoof connection, you can actually break IP-based authentication. All right. So where have I seen this? Let's see. Dakota Marketing and Research before they went under. Epic Systems, Eurodebit, CC Bill, iBill. That's just 5 off the top of my head. And those are all major credit card clearing processors. All of them do this. They all have just straight IP-based authentication. If it's from this IP address, you can run this CGI script and add users, delete users, whatever. It's really stupid. CC Bill, I'm sorry. And Epic Systems, that's 6. Dakota Marketing Research had some other problems with them. They did stupid stuff like gave global passwords out to everybody. Like if you were an administrator, you didn't even have to prove you're an administrator. You just have to call them and say you're an administrator and say you forgot your password. And they give you an admin password that works on every site for that day. It was pretty lame. And they also, I broke their authentication system in 5 seconds. It was same username, same password. Let's see. Okay, so blocking. You really have a couple of choices. You can do something like I said, send them to a deny access web page and make them call in, or that's what like E-Trade does, and all the major banks and financial institutions do this. You can also do something like connect it to IP chains or a hardware firewall, add them to an ACL or something, which can create a denial service without any human logic. That's pretty obvious. I really recommend the first one. I realize that that's kind of a management issue, how much time you have to spend on this. If you really want to have the manpower, someone manning the phone saying, okay, yeah, I'm gonna reinstate your password for you. It's pretty lame. But it does solve the problem of accidentally causing a denial of service attack on valid users. You never have that problem. Okay, so alternatives. Auth type digest. It's great. I can't say enough good things about it. It has a lot of the problems that it has solved a lot of problems that basic type authentication has introduced, but it also is subject to a lot of others, and it's really not that much better, unfortunately. It has some basic flaws. But essentially what it does, for those of you who don't know, is it takes a hash based off of a one-time number that the Apache gives to it, and that one-time number is a shared secret. Both parties know about it. And it takes that information, appends, I think, a date stamp or something, plus the you do this, I'm sorry, as a client. You append your password plus this one-time shared secret, and then the machine on the other side does the exact reverse on that same function. Since it's a cryptographic hash, all it has to do is check to make sure that that information is correct. It doesn't actually have to know your real password, and it's much more secure. It's considered computationally unbreakable. It's 2 to the 128 bit encryption or whatever. Basically, that's true. I mean, for all intents and purposes, no one's actually going to try to break this password unless you have some really big secret, in which case you probably shouldn't be putting it on a website. But it won't stop brute force attempts. That's the one problem with it. You can still do stuff like put a in there and still connect to the website and still try passwords over and over and over again and still disconnect when you get the headers. It doesn't actually really solve the problem at all. It's just obfuscated it. The only upside to this is no one's ever actually written this tool. So not because it can't be done or it's not especially easy to do, it's just that there isn't a need because not really many people use digest. Okay, I do have plenty of time. All right, Proxy Server. This is an idea that I said Vacuum gave me, which I think is a really, really cool idea for any big companies out there. Anyone who wants to make this, just let me know, I'll help you. What you can do is you could have, you still have machine A and machine B here. And instead, machine B is no longer trusted. Machine B connects to the website, and you have to have something in between it to stop it. And right now we're using htaccess script and modauth external. It doesn't actually have to be on the server, though. You can put it outside the server on a proxy server that takes all individual connections, does a translation on them, figures out, you still have to have some sort of list to tell it where and what to protect. But you can take care of all this headers munging and content, I guess kind of warping, to change it have this frame set. you can take care of it all on the proxy server level. You don't actually have to put this on your server, which opens you up to avenues, but putting, protecting ASP scripts, all different types of operating systems. It's universal. It doesn't actually care. You can actually change your operating system, and it still wouldn't care. It's independent. It doesn't care at all. The only thing that's kind of scary about this is that you would have to have some sort of, you'd either have to have no protection on your actual web server, which is kind of iffy, or you'd have to have some sort of trust-based relationship between the proxy server and your the actual web server, which is also kind of scary. But this could be used if you were to build it into an IDS or a firewall. You could actually take care of the second version. You could actually do the second version of blocking that I was talking about, which is, I don't recommend, but you could actually build this into a really sophisticated product because it could actually tell how many connects from where. It would be a very cool product. I want to build it. So basically, in conclusion, htaccess can be a robust solution. It does have inherent flaws. It does have some major security risks that no one's really figured out. So our Japanese connection has to leave. They were doing they were all translated over an FM channel. It was pretty cool. Essentially, you can make htaccess very secure if you do a little bit of work. You kind of have to believe that this work is worth what you're doing. From what I've seen, to build this exact system takes, probably about a month's worth of work to totally test it, to get it up and functional. So if you have that kind of time, this is all open source, which is really nice. It can, all this stuff is being developed independently by independent people. Apache is open source. You can put it on Linux or Solaris or whatever you want. It doesn't really matter as long as it runs. Actually, this does not work under Apache for Windows, and that's because Jan, who's the guy who creates mod auth external, says there's some problems with I don't know, directory structure or something. I don't know. It doesn't work under that, but it does work on all the Linux, Unix variants. Well, yeah. On shocking.com /htaccess.html, there was supposed to be this whole document printed out for you, but I was told by Security Focus that they didn't want me to have it on the website, so I had to take it down, and instead it says there's going to be a link to Security Focus, but I haven't done that yet, and I don't plan to anytime in the near future. So just go to Security Focus, ignore this link, and you can find out all this information plus a whole lot more. And that's pretty much it. Does anyone have any questions? No? All right. Well, thank you for coming. Go have some lunch.